few to take today. We're going to look at two concepts that are very much related called domain and range. Now, when you have a function that generates a curve or a line like this, there will be limits on how much of the x values are possible and how many of the y values are possible. And very simply, domain is the set of all possible x values, and range is the set of all possible y values. Now, some notes on notation, because you won't have seen some of this notation before. There's two different types of notation. We can either use something called set notation, which uses inequalities like this. So, for example, this is x is between a and b. Or interval notation, which means that x, that little symbol means is such that, or exists in, a and b. Note here, square brackets mean we include a and b, whereas round brackets mean we do not include it. So you see here how this one is saying that x is from negative infinity up to but not including a. That curved bracket relates to that hollow dot there. Similarly, that strict inequality indicates that a is not included. Alright, there's two different ways to write it. You need to know both because both might come up in questions, but you don't need to answer in both for answers. You can choose whichever works for you. This here means or the fancy word is the intersection. You might have seen this in set theory when doing Venn diagrams last year. Don't freak out. You don't have to use that. You can just use the word or. If you completely forget all this and all this, but you still need to write something as an answer, you can just write it in an English sentence. You can say that x is up to but not including a, or greater than but not including b. That would be fine. It would just take longer to write, which is why we like these nice mathematical shortcuts here. Alright, here is some more examples of set notation, interval notation, what this looks like on a number line, and if everything else goes wrong, what it actually means in terms of a sentence. You're welcome to print this off the OneNote or copy it out of your textbook. Either way, you need to have a very good idea of how to restrict the values that x can be. And that's what all of these are fundamentally doing. They're really cutting down what x can possibly be. Alright, so finding domain and range. The way you go about finding domain and range is think about, well, what possible values can x take? And then say, alright, well, given those values, what possible values can f of x or y take? Now, you might be thinking, well, what do you mean, what possible values can x take? Well, let's think about f of x equals x squared. What values can go into x squared? Can we square minus 3? Can we square 0? Can we square positive 3, positive 10, etc.? And you're probably thinking, yeah, you can square minus 3, you can square 0, you can square positive 10. Really, any value of x is possible. And that's why we say that x is a member of the reals. This here just means real numbers. The fancy way to write it would be like that. So you sort of do two lines and use the second one you draw to make the R. Or some sort of curly R that looks a bit different to a normal R. Alright, now given that x is a member of the reals, what about the range of f of x equals x squared? Well, if you think about what that looks like on the graph, as you all know that f of x equals x squared looks like this. So no matter what value of x we put in there, x squared is always going to return a positive. So f of x is such that its range must be greater than or equal to 0. The range here, or we can say f of x is greater than or equal to 0. So the thought process is, well, what values can x take? Good. Given that, what values can y take? So here, the range is real. Sorry, the domain is real. The range is positive. What about root x? Well, if you think about root x, you can't square root a negative. Square root of minus 4 comes out with 2 times the imaginary number. I'm not sure if you've done imaginary numbers or not, but either way, you can't really do it. It doesn't exist in the real realm of maths, So therefore, you can never put a negative under a square root. So whatever goes under there must be positive. And when you square root a number, well, no matter what you're square rooting, that will always come out as greater than or equal to 0. So here, x is greater than 0, and the range is also greater than or equal to 0. What about 1 on x? What values can you substitute in the bottom here? Can you put in negatives? Yeah, sure. You can have a negative fraction. Can you put in positives? Sure. Can you put in 0? No. You cannot divide by a negative, so you'll never have a negative underneath. So we just write, well, it can be anything, but x is not 0. Alright, given that x is not 0, what about the range? Well, this function here looks like this. Probably seen that before. Note that anything's possible here, except f of x is equal to 0 is the asymptote, so we would say it's also not equal to 0. And if you can't picture that in your head, great news is you have a calculator. So you can throw up your calculator and write, well, let's see what 1 divided by x actually looks like. Graph it. And yeah, you can think, well, it's going to hit every single y value except 0. What about 1 on root x? Well, this is starting to combine what we had before. You can't have it equal to 0, so it combines those two, meaning it must be strictly greater than 0. Alright, so hence remember, squares and square roots always return a positive value. What about the domain and range of this? Now you can see that's a quadratic. So, and you can see it's a positive quadratic, meaning it's going to be a smiley face. It'll look something like that, or that, or that. Either way, x will be a member of the reals, because we can substitute any value of x in there, and we're going to get a real number. Now, it won't have a range of everything. So domain is easy. But what about the range? We know that at some point it's going to have a minimum, so it won't contribute to everything there. Well, it won't have every possible y value. So, a couple of options what we can do here. Either we can say complete the square to find the turning point, or perhaps the fastest way is use your calculator. So if we use our calculator, apologies, I haven't used these calculators before, so they're all a bit different. And we put the value in there. X squared take 5x. X squared take 5x. What was it? Plus 6? Plus 6. Alright, here we can see that some values of y aren't applicable. So menu, gsolve, whoops, 5, gsolve. We want to find the minimum, so that's F3. We don't want to use that graph, we want to use this graph, so hit execute. And we can see that the graph goes down and touches at -1/4 and it goes up from there. So we can say that the range is such that you can either use 2 dots or a line is such that f of x is greater than or equal to -1/4. Alright, so everything above -1/4 is fine, nothing below it. And you can visualize that there. Alright, a harder one. Consider what values of x we can put in the bottom. Alright, what values of x we can put in the bottom? We can put any number in there, but we can't divide by 0. So the domain here is x such that x is not equal to -2. Because if we put -2 in the bottom, it would be equal to 0. And we can't divide by 0. What about range? Well, range, note how this square here is underneath, which means that's always going to be positive. So we're going to have 1 divided by a positive number. And that's going to be 1 divided by a positive not 0 number. So the range is such that f of x is always greater than 0. And you can check that on the calculator. Note that it's not greater than or equal to, it's just greater than. Alright, last one, domain. What possible values of x go in there? Well, you must square root a positive. You can't square root a negative. So we're really looking at, well, for what values of x does x squared take 9 greater than 0? Greater than or equal to 0. We can see that this will work if x is greater than or equal to plus or minus 3. Which sounds like an odd way of saying it. In fact, that probably isn't technically right. What we're after here is that x is either greater than or equal to 3, or x is less than or equal to minus 3. Why does less than or equal to minus 3 work? Well, if you think about it, if you substitute x equals minus 4 in there, minus 4 squared is going to come out as positive 16. Positive 16 take 9 is positive, so that works. So here we would say that the domain is x such that x is greater than or equal to 3, or, you can write or do intersection, x is less than or equal to minus 3. Alright, what about range? Well, range of this, it's a square root, so square roots always return a positive. No matter what number we put in there, it will be a positive. It can be equal to 0 though. So here range, because you square root 0 you get 0, is f of x such that f of x is always greater than or equal to 0. Alright, sorry that's a long video. To check your understanding, can you tell me the domain and range of that function? If you got that, fantastic. Note that I've used the other notation there. So there you go. Thank you very much. I'll see you in class tomorrow. Stop recording.